So let's talk about the structure of the galaxy we know best, the Milky Way. Now, even though we know it best, we're at a bit of a disadvantage because we're inside the Milky Way. So if we try to take a galactic selfie, we're only going to get a picture of what's sort of in our area. We can't just travel outside of the Milky Way and take a picture. So we try to map the Milky Way from inside. But a lot of what we know is based on looking at other galaxies like the Milky Way, other spiral galaxies. So I have here, very badly drawn, a face-on view of the Milky Way and an edge-on view of the Milky Way. There are much better diagrams in the book. But here we have the nice face-on view of our spiral galaxy. We have our spiral arms. And you are here. You are on the edge of one, actually a spur of a spiral arm. And again, looking at the video on spiral arms, you'll learn more about the fact that even though we're here now, we're not always going to be here, nor have we always been here. Here we have the center of the galaxy, the central bulge. Shows up a little bit better on the side view, but you lose the nice spiral structure. So you figure out with this edge-on view that the spiral arms are actually very thin. And the bulge is called the bulge for a reason, because it bulges out. Think of a fried egg on its side. That would be the yolk of the egg, and this would be the white of the egg. So the spiral arms are here in the disk. There's the central bulge, and surrounding that is what's called the halo. The halo has globular clusters of stars and a lot of very old halo stars. In the spiral arms, we have the youngest stars, because that's where stars are born. In the central bulge, we have a different population of stars. So stars in different parts of the galaxy actually represent different generations. They were actually born at different times. Because they're born at different times, there's been a different amount of recycling. Remember that stars create elements in their central furnace, in their cores, as they go through their lifespan. And then when stars die, that material goes back into the interstellar medium to be recycled into the next generation of stars. So stars that are currently being born in the spiral arms have a much richer chemistry than those older stars out here in the globular clusters.